Imagine a world where your smartphone, your electric car, and even your country's defense systems suddenly grind to a halt, not because of a global power outage or a financial meltdown, but because of a handful of obscure minerals you've probably never heard of. These are the rare earth elements, a group of 17 metallic elements that are small in size but massive in importance. From the motors in electric vehicles, EVs, and the magnets in wind turbines to guidance systems in advanced fighter jets, rare earth metals quietly power the technologies we rely on every day. Yet a single country, China, currently dominates the mining, refining, and production of these critical resources. This near monopoly has sparked concerns of supply chain vulnerabilities, possible shortages, and even a behind-the-scenes geopolitical race. In today's video, we'll explore what makes these minerals so important, why China is at the center of the rare earth universe, and how governments around the world are scrambling to secure their own supplies. Welcome to the hidden war for strategic resources that could reshape our future. Despite their name, rare earth elements aren't exactly rare. In fact, the term rare earth is historical. Some of these elements are as common as copper or lead. The group includes elements like neodymium, praseodymium, dysprosium, and yttrium, names that sound like they've been plucked straight from a sci-fi novel. They're scattered throughout the Earth's crust, but the challenge lies in finding them in concentrations high enough to be economically viable to mine. So why are they so special? One word: magnetism. Many rare earth elements have unique magnetic properties that are essential in creating powerful, yet lightweight magnets. These magnets are at the heart of motors in electric vehicles and turbines in wind farms. Rare earths also possess luminescent and catalytic properties, making them indispensable in everything from LCD screens and lasers to advanced weaponry and satellite communication systems. The modern tech-driven world cannot function without them. If you drive an electric car, chances are its motor uses permanent magnets containing rare earth elements like neodymium and dysprosium. Wind turbines, especially the large-scale offshore versions, rely on similar permanent magnet systems to generate clean energy. Beyond green tech, these elements are crucial in consumer electronics. Smartphones, tablets, and LED lights often incorporate rare earth compounds. But it's not just about civilian life. Rare earths enable key aspects of national security. According to the US Department of Defense, advanced military jets, missile defense systems, and naval radars all depend on rare earth materials for performance and reliability. Global powers can't afford to lose access to these elements. Losing them would mean losing a technological edge. This is precisely where China's dominance raises significant concerns. China's rare earth story began in the 1980s and 1990s, when it heavily subsidized the mining and refining of these elements. Gradually, as environmental regulations became stricter and labor costs rose in other parts of the world, many mines outside China became less competitive or shut down. By 2010, China controlled over 95% of the global rare earth supply chain, from extracting the ore to refining it into useful oxides and metals. Although that share has somewhat decreased in recent years, China remains the powerhouse, with the US Geological Survey estimating that China mined about 58% of the world's rare earths in 2022 and refined even more due to its processing capacity. This dominance isn't just about who mines the most, it's about who can process and refine these elements at scale. Rare earths aren't valuable straight out of the ground. The real challenge comes in the chemical separation and refining processes, which are complex, environmentally hazardous, and energy-intensive. China has built an extensive infrastructure to handle these stages, making it difficult for other nations to catch up. Rare earths may enable clean energy technologies, but extracting them is anything but clean. Mining rare earth ores often involves open-pit excavation, generating large amounts of radioactive and toxic waste. The refining process uses harsh chemicals such as acids and solvents to separate different elements, creating waste lagoons that can contaminate local waterways and ecosystems if not managed carefully. China has faced criticism for lax environmental standards, especially in areas like Inner Mongolia, where tailing ponds can stretch for miles. Local communities suffer from pollution-related issues, and the land often becomes unsuitable for farming. As global demand for rare earths rises in step with the green energy boom, the environmental toll becomes a significant concern. This raises a complex question. How do we maintain a sustainable supply of materials that are essential for low-carbon technologies without causing massive ecological damage? Rare earths are not only critical for technology, but are also a lever of geopolitical power. When diplomatic tensions soared between China and Japan back in 2010, reports indicated that China temporarily restricted rare earth exports to Japan. This triggered alarm bells worldwide, illustrating how control over critical resources can be used as a bargaining chip. As global reliance on these elements escalates, many nations worry about a hypothetical scenario where China could curb rare earth exports for political reasons. Even the slightest supply constraint can send shockwaves through industries that rely on these metals. The fear of a sudden shortage could lead manufacturers to move their supply chains or scramble for alternative materials. Aware of these vulnerabilities, countries like the United States, Australia, and Japan are investing heavily in developing alternative rare earth supplies. For instance, the US has partially revived the Mountain Pass mine in California, which was once the world's leading rare earth mine before environmental and market pressures forced its closure. Now operated by MP Materials, Mountain Pass produces a significant amount of rare earth ore, though much of the refining still takes place in China. Australia has also ramped up efforts through companies like Lynas Rare Earths, which operates the Mount Weld mine, one of the highest-grade rare earth mines in the world. Lynas has processing facilities in Malaysia and is working on establishing refining capabilities closer to the mine to reduce dependence on China. Japan, South Korea, and members of the European Union are also exploring stockpiling strategies and building refining infrastructure. The goal is clear: minimize reliance on a single source. However, building a robust, diversified rare earth supply chain involves substantial costs, years of development, and tight environmental regulations that can slow down progress. Another avenue for reducing China's stranglehold on rare earth metals is through research and innovation. Scientists are exploring the possibility of recycling rare earths from electronic waste. The idea is to reclaim metals from discarded smartphones, batteries, and wind turbine components rather than continually mining new ores. Although e-waste recycling is still in its infancy, it has the potential to supplement supply and reduce the environmental impact of mining. Moreover, alternative materials are being developed that can perform similar functions without relying on rare earth metals. Researchers are investigating new magnet designs that use less or no rare earth content. While these alternatives aren't always as efficient or widely available yet, they represent a crucial safety valve if supplies become constrained. According to some industry forecasts, the demand for rare earths, particularly those used in permanent magnets like neodymium, praseodymium, and dysprosium, could outstrip supply in the next decade. The rapid expansion of electric vehicles, renewable energy, and cutting-edge electronics means the world will require a lot more rare earth elements. If current mining projects and refining capacities don't expand in time, we could face a supply crunch leading to higher prices and potential bottlenecks in product development. This shortage wouldn't just make EVs more expensive, it could slow the entire transition to green energy, delay technological advancements, and compromise national security for countries that rely on these materials for defense. As the rest of the world attempts to reduce dependence on China, new mining projects are popping up from Canada to Africa to Southeast Asia. But each mine comes with its own environmental and ethical implications. Local communities often worry about pollution, habitat destruction, and displacement. On top of that, the refining process remains hazardous if not regulated properly. There's also the question of who benefits financially. Countries rich in rare earth reserves could see an influx of investments. But without strong governance, the revenue might not trickle down to the communities most affected by the environmental impact. Finding a sustainable approach, balancing economic benefits, environmental safeguards, and fair labor practices will be critical as global demand surges. So, where does this leave us? Rare earth elements are here to stay. They're integral to the technologies shaping our modern world, from electric cars and wind turbines to smartphones and stealth fighters. The question is how to secure their supply ethically and sustainably. Diversifying the supply chain, investing in research and development to find alternatives, and enforcing strict environmental standards in mining and refining processes will be paramount. China will likely remain a central player, given its decades-long head start. However, countries around the world are making moves, reopening mines, building refineries, stockpiling minerals, and fostering international collaborations. The stakes are high. Whoever controls the flow of rare earths controls the backbone of many essential industries. Whether we're talking about the next generation of green technology or advanced military hardware, one thing is certain. Rare earth metals are not only valuable commodities, they're strategic assets that can shift the balance of global power. If you want to keep an eye on the future of technology, national security, and international diplomacy, keep an eye on the rare earths. And that's the big picture, a hidden war for strategic resources that might seem invisible on a day-to-day basis, yet underpins the gadgets, vehicles, and infrastructures we can't live without. If you found this video insightful, be sure to like and subscribe for more deep dives into the technologies and economic forces shaping our world. Leave us a comment below and let us know your thoughts. Should countries speed up domestic mining and refining at the risk of environmental harm? Or are there better, cleaner ways to secure these all-important elements? Thank you for watching, and stay tuned for our next exploration of how science, technology, and geopolitics collide to shape our collective future.